Hi everyone, welcome to my YouTube channel TechDataEngineer. So today in this video I will see system design concepts for data engineering. Okay, so in this system design courses I'll explain the things related to only data engineering. Okay, so I have divided the entire system design things into multiple layer. Okay, different layer where I'll explain the data ingestion layer, storage layer design, then how processing will happen under data processing, then streaming system design, then orchestrations and workflow design, how we will do the data modeling and what are the concepts related to that, data warehousing design, and then ETL, ELT design, data quality and validations, metadata catalog and API microservices that is basically only for the data engineers. Okay, then scalability versus performance, reliability and fault tolerance, and security and governance. Then we'll see the cost optimizations, how we'll do in the case of system, entire system design, then end-to-end pipeline architecture. So these are the subtopics which we will cover in the upcoming video under the entire system design concepts. Okay. So first we will start with the data ingestion layer. So how we are designing the data ingestion layer, and then we will see storage layer, distributed processing and all. Okay. So now let us start with the like data ingestion layer. So this is the snapshot of the entire data ingestion layer, where I will explain what are the types of ingestions we have, like batch ingestions, streaming ingestions, API based ingestions, okay, and many more. I'll explain multiple types of data ingestions, and then what are the concepts of pool versus push ingestions. In which scenario, if whenever you are designing the system, then in which scenario you have to consider the pool, when you have to consider the push ingestions. Okay. And now then we will explain the data ingestions reliability mode, like at least one semantic, at most one semantic, exactly once. So in which scenario, whenever you are designing the system, you require at most or exactly one semantics is with respect to data. I'll explain that. Okay. So this is the snapshot for our entire data ingestion layer concepts. Okay. Now start with the data ingestions. Okay, so as everyone know, I mean, this is the very basic but still very important. So I'll start with the data ingestion. So what is data ingestion? So data ingestion is nothing but injecting the data to your system. Okay, source system, your data system like data lake, data warehousing, streaming engine, or wherever you are doing the processing. So ingestion is like bringing data from the different sources. Different sources means either from the DB, either through the some of the file system, either scrapping from the different web, or either from IoT system server. So if you are collecting the data, bringing data from different source into your data system is called the data ingestion, ingesting your data to your data system. Okay. So what are the types of data ingestions we have? In data ingestion also there are five types, five category. Okay, so we have batch ingestion. So what is batch ingestions means? So batch ingestions what it do? It collects data from sometimes and then lead together in one sort. So you can say it will collect the data in the batch way. Okay, batch way means we are not delivering some product one by one. We are collecting the 10 products and then again we are going and delivering to the some different destination. Okay, so that is we are making a batch and then we are delivering the data. So in batch ingestions we are using the tools like Airflow for schedules, cron job, flow or Spark. If we are using bulk load, we are using the batch ingestions. Okay, then other concept is we have the streaming ingestion. So in batch ingestion, when we are using batch ingestion, I'll see like tools we I have already explained. But in case of if you are using the daily sales report, hourly log ingestions, nightly ETL, so in that case, hourly, daily, nightly, you can do the batch and then you can give the report. Okay, so this is the example of your batch ingestion. Okay, so if we understand from the normal day-to-day life analogy, so we can understand like okay, collecting garbage every morning. Okay, so instead of picking up each paper instantly, what we are doing, we are just collecting the every garbage in the morning. Okay, that is the example of batch ingestion. What is streaming ingestion? So streaming ingestions is basically consumed as soon as it is getting generated. So whenever data is getting generated, it at the same time it is getting consumed from the your system also. Okay, so that is the example of streaming ingestions. So if you'll see the real-time example, we have Kafka, PubSub, Kinesis. So Hotstar or live streaming is the example of why YouTube live streaming is the example of streaming ingestions. Okay. So when this scenario is required, so when we are using like user clicks a website or IoT sensors sending temperature every second, or if there is a concept of real-time fraud detection, so in that scenario you will use the streaming ingestions. Okay, so that's why system design concepts is important, because you will get to know that in which scenario you have to design that system. Okay. So tool I have already explained, we are using the Kafka, PubSub and Kinesis. Okay. Then the third concept is change data capture. Okay. So change data capture means only it capture only the change happening in a database. Okay. So let us see example. So our sources, our system, data system in the got data ingested till 10 p.m. Okay. Then till 10th, then after that 10 from data again came to your system, and we have data from till 10 to 10:30. So not the entire data till 10 p.m. 10:30 p.m. will get ingested. It will only ingest the incremental data, like from 10 to 10:30, whatever the data came that got ingested. That is the example of change data capture. Okay. So, example we can see like new row inserted or existing row updated or row got deleted. So these are the example of change data capture. Okay. So when to use that? So when to replicate the data from OLTP DB or warehouse. Okay. Or if there is a real-time DB sync or incremental JSON is there, so then we can use change data capture. Okay. So we have some tools to handle that. We have Division have we have Golden Gate, we have 5-term CDC. Okay, these can handle the CDC. Okay. So if you see some example, real-time examples like tracking only the edits in the Google Doc rather than storing the full document again. Okay, that is the very good example of change data capture. Now the next concept is API based integration. Okay. So in API based integration, so when you make a API call to another system and then fetch the data, you make a call, then data got ingested. That is called API based ingestion. Okay. We are using the Python scripting, Airflow operators or REST API client mode. Okay. So when we required API injection, so suppose we have fetching weather data for every 5 minutes or pulling stock price data or reading data from the any Salesforce or integrate Instagram API, then we are using the API integration. If we are reading data from some in API like Instagram API or some other API, so we are just calling the API call and then we are getting the data and storing to our system. Okay, that is called API based ingestion. Now we have the file-based ingestions. So file-based ingestions when we are using, so that is for like many system drops files like CSV, JSON, Paraquet we have, and we are storing directly to the storage locations. Okay, in storage locations we have like many file system, and then we are storing to the our system. Okay, data system. So that is example of GCS, S3, GCS we have in Google, S3 we have in our AWS, and then HDFC Hadoop system, that is open source. So these are the file-based ingestions. Okay. So when we are using that, so like if we have the bank uploads CSV file daily or logs file from the server or export data from some ERP system like Oracle we have ERP system. So if we are exporting data from the ERP system, we are using the file-based ingestions. Okay. So these are the different types of ingestions we are using. Okay. In which scenario, what are the tools we have? So I have explained this all. Okay, these are the very basic, but this is very important to understand also. Okay. Now there is a concept called pool versus push ingestion. So what is pool? What is push ingestions? So pool ingestions is required like when your system goes and fetch the data. Okay. like Airflow job pooling API data, or we have cron job that is reading data from the FTP server. We have a Spark job reading data from the database every night. So your system goes and fetch the data. So that is called pool ingestion concepts. Okay. So you might get asked questions like what is pool ingestion, what is push ingestion. So pool is like going and storing the. So pool is suppose if we understand the real-time analogy. So we have I'm going and buying milk from the store. Okay, that is called pool ingestion. So what is called push ingestion? So push ingestion is like our source system send data automatically to your system. Like so when source system sends data automatically without your data system go and pick the data, that is called push ingestion. So push is ingestions, the example like we have Kafka producer. So Kafka producer produce the data, that push the data. We have database sending CDC data change, event change. We have webhook who is pushing data to the endpoint. Okay, these are the example of that. So if you'll understand with our analogy, we have like milk being delivered to your locations. In first part, what we are doing, we are going and we are picking we are getting milk from the store. Okay, but here milk automatically getting delivered to your location. That is called push ingestions. Okay. Now one more concept I'll see here. What is called real time, near real time, and batch. So real time means data arrives instantly. Okay, within millisecond. We have Kafka, Flink, PubSub are the example of real time. And if you'll see, we have live streaming, Netflix, and all these are the example of real time. What is called like so when we are using real time, if we have the fraud detections or live dashboard required, you can see the real time. Okay, real time data. What is near real time? So data got delivered, data is delayed by a short interval of time. It got delivered instantly, but there might be a delay also from 1 to 15 minutes. That is called near real time. Like if you see the some example, like we have mobile app sync every 5 minutes. So that is the example of near real time. Then we have the data refresh every 10 minutes or 5 minutes. That is also example of near real time. Like suppose so whenever we are checking email, like something it's come instantly, something a fewer minute. So that is the example of near real time. Okay. Now we have the batch. So what is batch? So data arrives after a fixed schedule like hourly basis, daily basis, weekly basis, monthly basis. So we can use tool like Airflow, cron job. These are the example of that. Okay. So suppose we require monthly billing or monthly report. So these are the examples of batch. Okay. So now we understand real time, near real time, and batch system. Now, moving to the next thing. So we have the data ingestions reliability modes. Okay, so these are very important. Okay, whenever designing your system, so based on your requirement, based on your use case, you have to see what are the reliability modes we have. So there are basically three reliability mode: at least one semantics, at most one, and exactly one semantics. Okay. So what do you mean by that? So at least one semantics means data is processed one or more time. Okay, at least one. So minimum one time data should be processed. Okay. So in this scenario, what happened? Duplicate may occur. Okay. So where it is getting used, it is used in Kafka or PubSub. Okay. So suppose you may get hello message twice, but you will never miss it. Okay. So acknowledging one or more than one time. So that is called at least one semantic. What do you mean by at most one semantic? So at most means data is processed zero or one time. Okay. So at most once a maximum one time should be processed. So in this scenario, what we will find? This scenario, no duplicate, but data loss may happen. Yeah, if there is some error happens, or definitely data loss may happen, but there is a guarantee that there is no duplicate happened in this system. So that is called at most one semantic. Okay, like we have SMS OTP, so sometimes you don't receive. It is not like that you will receiving two times. Either one time you will receive or you will never receive. Okay. So these are the example of that. And so where we are getting we are used, so low value data or logging we are missing a log is fine. So we can use at most one semantic. Okay. And the third, we have the exactly one semantic. So what do you mean by exactly one semantic? Data is processed only once. So in this scenario, what will happen? No duplicate, no loss. So when we are using this mostly in the banking system, financial transactions or billing system. Okay, so that there should not be duplicate or neither data loss. Okay, so whenever we are designing our banking system, we will use the exactly one semantics. Okay, so example like Flink, we have exactly one semantic, Kafka transactional write, BigQuery streaming insert with a duplicate key. So these are the example of these are the tools and features we are using. Okay, so like when you're so if you see the example, so when you are transferring 10,000, you can't pay twice or you can't skip the payment. So these are the example of exactly one semantic. Okay, so these are the concept basically we have in case of data ingestion layer. Okay, so next video we will see what are the storage layer design, then we'll see the distributed processing. If we'll see each and every concept, then we will see end-to-end the pipeline designs also, like how we are designing the system. So that concept also we will see. Okay, thank you, thanks for watching.